This is a video on analyzing functions. So that's something we're going to be doing a lot this quarter, where we get a new function, we want to analyze it, which basically we're just kind of looking at the different aspects of it. And as we go along and we get more and more complicated functions, we'll add to the list of things that it means to analyze. So right now, some of the things we've talked about is domain and range, and we've already talked about that a little bit. The intercepts, that's something that you've definitely done before you got to this class. You should have found the x and y intercepts of a graph. And so the new stuff is that talk about where the graph is increasing and decreasing, and sometimes we might even talk about the slope. And then also symmetry. For right now, we talk about does the graph have symmetry, and a specific aspect of symmetry is whether it's an odd or even graph. So we're going to take this one function here, f of x equals x squared minus 2, and talk about it for each one of these topics. So domain and range, we've talked about this, that domain is a list of all possible x values. And I think the best way to deal with domain is to just assume the domain is all real numbers, unless there's a problem. And the problems that we've talked about in class is dividing by 0 and the square root of a negative number. So you're asking yourself, is there any number I could plug in for x that would cause me to divide by 0 in this function? And of course the answer is no, because there is no division in this function. And then the second question is there any number that I'd plug in for x that would cause me to take the square root of a negative number? And there is no square roots in it, so the answer is no to that also. So the domain of this would be all real numbers. Now the range is, I think, easiest handled if you graph it. And so in theory, you guys are familiar with quadratics. This is a quadratic that has which means that the graph is going to be a parabola, which means that, and it's got a positive leading coefficient, so it's open up. And this minus 2 basically moves everything down 2. So that means the bottom of the parabola would sit down here at negative 2, and it would look something like this. Now, of course, you didn't know all that. You could just plug in numbers. Like, for example, you could take f of 0 to see what it is. When you plug in 0, you get negative 2. You can plug in f of 1 to see what that is, and you get negative 1, etc. Or you could throw it in a graphing calculator and take a look at it. So what we'll find out is that the bottom of this is negative 2. So the lowest it can go is negative 2, and it goes forever up. So we put infinity in here, and that would be the range. The x and y intercepts. The y-intercept is pretty straightforward. You can see it sitting right there. It looks like it's 0, negative 2. The x-intercepts, a little bit harder to come by. They're going to make us work a little bit. And the general rules when you're looking for intercepts, if you're looking for the y-intercept, you plug in 0 for x. If you're looking for the x-intercept, you plug in 0 for y. So since I'm looking for the x-intercept here, I'm going to take x squared minus 2, and I want to know when is that equal to 0. Again, because if y is equal to 0, you're sitting on the x-axis. So this would be x is equal to 2, or x squared is equal to 2, which means x is equal to plus or minus the square root of 2. So the x-intercepts would be square root of 2, 0, and negative square root of 2, 0. Okay, moving right along. Increasing, decreasing. So we would want to be able to talk about where is this graph increasing and where is it decreasing. Okay, the idea of increasing means as you go from left to right. Is it going up or going down? So you notice in the graph from here over, as we go from left to right, it's going down. And from then on, as you go from left to right, it's going up. So increasing would mean the point to the left, the point to the right of the point I'm looking at is higher. So notice if I pick any point in here, if I go to the right of it, I have to go up to get there. So that's increasing. So the way we describe this is we would say that the function is increasing from 0 to infinity. Notice I put a soft bracket on 0 because it's not doing anything at 0. It's flat, neither increasing nor decreasing. And it's decreasing from negative infinity to 0. You can see in this case I'm describing the green, and in that case I'm describing the pink, or whatever that color is. Okay? Now if we wanted to get a little bit more detail about the increase and decreasing, we could talk about slope. Now of course if you look at this graph, it's the slope is changing all the time. So in this case we could talk about the average slope. So for example, we could calculate the average slope over the interval, say 1 to 2. So if you want to get a picture of what that looks like, that means when x equals 1, I'm right there. When x equals 2, it looks like I'm right about there, right? So I'm trying to find out the slope of a line that goes through those 2 points, okay? Which is not the actual slope of that point there, but it estimates a slope along that part of the graph. It is the average slope along that part of the graph. Okay, so of course the way I would do that, just like we used to always find slope, we would do f of 2 minus f of 1 divided by 2 minus 1. And of course f of 2, that means I'm plugging 2 into the function. The function is x squared minus 2, so that would be 4 minus 2, which would be 2. And f of 1, that would be 1 squared minus 2, which would be a negative 1. And then 2 minus 1. So that would be 3 over 1, or 3. So the average slope over the interval from 1 to 2 is 3. Okay, there's average slope. And then finally symmetry. You can look at this and tell that it's symmetrical about the line y equals, or about the y-axis. So you could talk about symmetry in that way. But there's also some terms, odd and even. An odd function, let me go down below here. An odd function has what is called point symmetry. Which means that if you rotate it around a certain point, or actually it has point symmetry about the origin, not just any point, but about the origin. So that means if you were to take the function and rotate it about the origin, a certain rotation, it would look exactly the same. So for example, the graph y equals x cubed is an odd function because it looks like this. So notice if you take this, put a little spinner, a little pin there, and spin the graph 180 degrees, this piece here would go down there, and that piece would go up there, and you wouldn't even be able to tell that it spun. So that is what is called, that's an odd function. Another way to think about it is in odd functions, f of x is equal to, f of negative x is equal to negative f of x. That's always true in odd functions. Now, even functions have line symmetry. That's a symmetry that you're probably more familiar with, about the y-axis, and just the y-axis. And an example of that is actually our graph that we're dealing with up here. That is an even function. You can notice if you reflect that across the y-axis, the pink goes where the green is, and the green goes where the pink is, and you wouldn't be able to tell any difference. So this function is an even function because it has symmetry about the y-axis. The other, likewise, as we said up here, the unique thing about even functions is that f of negative x is equal to f of x. If you plug in 2 or negative 2, you get out the same answer. If you plug in 3, negative 3, you get out the same answer. So that's a characteristic of even functions. So that's a quick little lesson on what it means to analyze a function, and also introducing two new ideas, even and odd, and the concept of average slope, which is not really a new idea, but we're applying it here, and also just increasing or decreasing, be able to talk about where a function is increasing or decreasing.